thanks for the invitation, Matt. And I'm, happy to try to show you what we can do here as a few examples using computational approach or AI approach for mental health. And that's my group. What we are doing basically is we look at the data using human and mouse data, for example, look at mental health. And then we also working on modeling and theoretical side for artificial intelligence. But today I will concentrate on this part, using AI, what we can do using AI for mental health. Just show you one very one example. They try to demonstrate what's the advantage for AI-based approach. For example, that's one of the comments after we publish a paper about on schizophrenia. And then actually she's a professor in Harvard University. And so after we publish a paper on schizophrenia and on language side, and she jumped up, basically, she loaded comments about our results on schizophrenia. And what we try to see in our paper actually say, the language pathway is very important for schizophrenia. And she said that, was nothing new there, essentially, because she already worked on this, the historical pursuit of the language pathway for many, many years. So what's new for our approach, using AI approach, basically using data approach, data-driven approach? And our answer to her comments is that, yes, you're already working on this for many, many years on schizophrenia, but essentially it's a hypothesis-driven approach, So she specifies languages as a problem for language pathway, and she look into language pathway. But for us, might be different. We're using the data, and so what we try to do is we don't have any hypothesis there. It's data-driven approach, and we identify the language pathway is the most important pathway affected in schizophrenia. So we look at the whole brain, and we identify the language pathway is the most important pathway, and then we concentrate on the language pathway, from data-driven to target-driven. So that's the approach we use. So it's possibly different from the classic or historical research pathway, and I think that's a power of our data-driven approach. And I will show you a few examples later on, more concrete examples here. So when we look at all these, we look at many diseases actually, for depression, addiction, schizophrenia, dementia, Parkinson, OCD, for example. So so sometimes I use different diseases as an example, try to tell you what we are doing. So we look at this disease at a microscopic kind of genetic level or cellular level, or more kind of brain image and the behavior level. And then we work out, for example, where's the origin, where's the root of disease, for example, depression, where's the root of the depression, and then we develop a methodology for prevention and for treatment. So I will explain to you, from the spatial scale, from micro scale to meso scale to macro scale, and then we develop the treatment or prevention side story, from very detailed level to the applications. For example, at the microscopic level, for the dementia cases, so we're using UK bank data, and essentially they have 50,000 people. They have around 2,000 protein available from all link. And what we work out is, so the question we ask for the dementia data or depression. We have work out a similar story for other diseases as well. For example, for dementia data, if you look at the protein here, and because we have this data available, and if you look at them, see, so that's the onset of your dementia, and it's very clearly you can see using the data, and you can see, say, 50 years ago around, that's a clear departure already. For example, for quite we selected 11 proteins here, for example, and so you can see, as that's a quite a clear picture there already using the data approach, and then we combine all these proteins. We select 11 proteins from. That's 2,000 protein. We select 10 of them around there, and then we use these 10 proteins and combine our machine learning approach, and we can predict, for example, 15 years ago, using all these protein panels and using our machine learning approach, and the AUC is around 0.91. So we can use the 10 protein, more exact, 11 protein, and combine our machine learning approach, and we can clearly predict the dementia 15 years ago, before the onset of the dementia. And
relatively young family.
Yeah, so as the paper was published a few months, 2 months back in Nature Aging, and highlighted in Nature, and that's the BBC News actually about, say, and it's not about our paper, but I say,
If the NHS does prescribe the new drugs, they'll only be available to patients whose Alzheimer's is at an early stage. So speedy diagnosis will be crucial.
Yeah, so say in one of the PBC program, they discuss about the importance of early diagnosis of the dementia, and in our paper, and it's highlighted in Nature actually. So that we told the story, we can, using all this machine learning and the data approach, we can early diagnose the dementia using our approach, basically using 10 proteins there. Yeah, so it's so it's at the microscopic level, at the protein, at the genetic level, using machine learning approach, I can tell you one example. Yes, just say for dementia, and we can work out a similar story for example, for depression as well, for Parkinson's, and also because of time, I don't have time go into details there, but then so that's one story for microscopic level, and I will tell you another story basically for macroscopic level. So I'll not go into detail at the cellular level there. So using for microscopic level, for example, at the excuse me, at the brain image level. And what we try to do is using all the data. For example, we're using sectional data. We collect a lot of data for depression people, and the question we ask there. So that's the data we have. We have one of the largest data for depression for brain imaging. So even a sectional data. So we collected around 4,000 people MRI data together. At one sectional data. And then the question we ask there is, can you use a machine learning approach to really say, first of all, subtype all these depression patients? And secondly, can you predict the disease progression there as well? So it's not only the subtype of them, and also can you work out, how the disease progression? Yeah, so again, I don't have time go into details, but as a part, you can find our publication there and read the details yourself. That's the background idea how we can do it. So using sectional data, we can subtype depression into 3 subtypes. One is ACC, starting from ACC, gradually spread. Basically, the brain shrink. Yeah, so the shrink is spread to all of the brain. The second subtype is starting from the hippocampus shrink, gradually spread to all the brain. And the third one is frontal area, for in particular like OFC, shrink start from OFC and gradually spread to all of the brain. So we can basically, say find all these subtype and then also predict how the disease progression there. And then, for example, based on one of the findings, so we know the OFC shrink is one of the starting point for our depression disease. Then we can aim for this area, say target on this area, we can develop the treatment and the prevention of it. For example, for the treatment, we can use TMS, say target your natural OFC and try to inhibit the signal here, basically, and we can, and it's subsequently our colleagues they prove it works. For the area we found out for the depression, for example. And also we can use this for this approach, look at the prevention of depression. For example, we can work out if you have a healthy lifestyle, we can reduce the depression risk by 57% of the depression risk. So basically, I tell you is, using this data, we can look at the disease at the microscopic, mesoscopic, and macroscopic level, and then finally we can develop all this, into the prevention and the treatment as well. So that's a special side. So that's a geometry scale. We look at the different scale here. What we're missing here is, of course, the temporal scale. So. Okay. So we can even enlarge this geometric side. We look at the environment as well, how the environment affect the environment affect your depression, for example. Again, if you have interest, you can read our paper there. So from say geometric side, we can have all these scale available, look at them in a more kind of global comprehensive picture as well. But what we're missing here is, of course, that's a section of data in time in the temporal side. And so we can not only look at this temporal spatial side, but we can also put all temporal side together. For example, we can have a longitudinal data, and then we can look at say what happens for example, for addiction, what happens for your brain. So we can have a picture in the spatial and the temporal scale as well. I say this will help us to explore the causality, for example, for addiction, why people start smoking, for example, and after smoking, after starting of smoking, then why you will become addicted to the smoking, for example, all this story. And so not only the spatial side, we can also look at the temporal side. How is the people, for example, substance as addiction people, for example, we can compare addiction with healthy people, and the discovery we have here is, for example, that's the healthy people, the brain size, and if you look at the addiction people for their lifespan, and that's the subcortex volume, gray matter of subcortex volume, and that's the gray matter volume of the cortex. And you can see, funny enough, for example, when they are younger, the addiction children, the subcortex brain is larger actually than the healthy people. And when they become older, and so the brain size for the subcortex actually is smaller than the healthy people. And the cortex is different picture here. So we need a kind of the panorama picture or comprehensive picture to understand the brain. It's not only the spatial side pattern changes, also the temporal side spatial changes as well. So that's my take-home message is here. So what we are doing for our AI side approach is we start collecting data. We have some of the largest data available, and then we use the AI algorithm. Then we try to have say discoveries. They try to identify the a starting point of the disease, for example, and then we can have the treatment and the prevention side of the story as well. And also, we can look at the spatial temporal. So that's not only spatial side, we can also look at a spatial temporal pattern. Then that's we very much believe. At the moment, so using all the AI approach, so we can identify the spatial temporal pattern change as well. And okay, I know my time is up, and then we can. So I tell you the story. So we look at the microscopic level and the macroscopic level and the treatment, and we try to unify them as well. So to unify, for example, as for schizophrenia, we unify the story, from the microscopic to the macroscopic. What happens, for example, the brain region shrink is linked to the neuron transmitter change here, for example, and the paper appear very soon in British Journal of Psychiatry. So we have this story, and I skip this part, man. Yeah, so I'm stop here. I try to convince the people maybe in the audience, using the AI and the data and combine with your knowledge, we can have some novel discovery and which will be useful for the treatment, for the prevention as well. Thanks.
Thank you very much, Zhanfeng. Can you hear us?
Yeah, I can hear clearly. Yeah.
Which means that we have a couple of minutes for questions. If you have any questions, if you speak up, then Zhanfeng will hear you out in Warwick. So any questions? Okay, so that's okay.
Thank you for that speech. So I've got a question about you mentioned a lot of the complex predictive factors. What would that look like if it was implemented? Would that be a national screening process to look at those proteins? Would that be interval MRIs? How would that actually look like in clinical practice?
Very good question. Thanks a lot. Yeah, so that's published 2 months ago, I think, in Nature Aging, and you can find the paper there. Yes, we can do it, and we try to develop this protein panel, for the early prediction of the dementia there. And to me, we did look at the image side and the protein side. As to me, that is the most reliable at the moment. The biomarker we have figure out at the moment. But the trouble, I can tell you, in clinical applications, the trouble. Actually, I talked to All-Link people a few weeks back. For each protein, to identify, to have the data for each protein, we have to, the cost will be, say, a few £100 for each protein, around £200 possibly. So if we want to identify this 10 protein, have this protein panel, that will be quite expensive. And we talked to the All-Link, and what we want to do next is possibly we can reduce the price. If we can reduce the price, that will be really useful. I hope at least, for clinical applications. Yeah, thanks.
One more question?
That's one more. Thanks for your great talk again. As the size and diversity of your samples has increased, as the diversity in particular of your samples has increased, so comparing, for example, Chinese populations with Western populations, have you uncovered any surprising differences?
Again, very, very good question. We did look into the dementia, depression, schizophrenia, and we did compare, for example, this was not a depression, but schizophrenia. We compare using Enigma data, compare Chinese schizophrenia and Enigma schizophrenia. And funny enough, what we conclude is we are pretty much that, schizophrenia is one unified schizophrenia. There's no Chinese schizophrenia and American schizophrenia. We are pretty similar. So It's a very good question. For the cases we look at, depression at the moment. We look at depression and schizophrenia already. They are pretty much similar to each other. Dementia, we don't have enough data at the moment. For example, the protein data, but that's the thing we want to have a look at as well. Yeah, that's another very good question. I think. Yeah.
Thank you.
Good.
Thank you very much for the invitation to come and speak today. I mean, I know what it's like to kind of be the token ethicist who works on large projects. And I guess what I'm going to try to do today in a very limited amount of time is perhaps explain the differences between some different kinds of ethics research, try to convince you that ethics is an opportunity, not a barrier, and try to outline some ways you could, or really one way, so very limited time, how you can potentially incorporate ethics research into research programs. I think most people are familiar with ethics as a governance process, something that's bureaucratic, something that puts barriers in the way to doing what you want to do. I have a colleague I do quite a lot of work with in Sri Lanka who likes the phrase ethics is a friend of research. And I think that's absolutely right, but it's not just to do with research ethics, there's also ethics research, and that's something people are a bit less familiar with potentially. I think I'm pressing the wrong keyboard, yeah, there we are. So to try and establish the difference between research ethics and ethics research, we can think of research of ethics in terms of ethics as governance and ethics as inquiry. And the aim of ethics as governance is to provide for the ethical conduct of research. It's basically this process we all have to go through to get ethics approval, to follow the rules, and essentially it's a dictum to behave. That we don't trust you, we know what researchers get up to, they'll get up to all sorts of things if there's not governance processes and a big stick that we can wave to say, you'll get this if you don't behave. That ethics as a barrier, I'm not saying that is not valuable, I think it is important, but there's more to ethics than that. That's basic ethics. That's the kind of stuff, you try to teach children. It's kind of parenting, it's just don't be naughty. What I'd like to encourage you is to think about ethics as inquiry. Ethics research as an opportunity to generate new knowledge and as a research activity in and of itself. And there's two kinds of knowledge related to the kinds of research you might be doing. There's new knowledge about how to undertake research ethically. So as new research develops, as we develop new ways of understanding the world with AI and in psychiatry, it may well generate new research ethics challenges. So if we're attentive to ethics as a process of inquiry, from the very beginning, we can be attentive to new research ethics challenges that might develop. So whenever people are asked to write in an ethics application form or a funding application, what are the ethical implications? We tend to go to the standard tropes, and I see quite a few that say, oh, there's none. And that's always nonsense. There's always some. There's some we know we can predict, and there's some we don't know about. So building ethics as inquiry into any and all research programs can help us identify and be attentive to new ethical issues in research, which means that when we come across them, we can deal with them in an appropriate way. Then we can also think about knowledge about ethics as inquiry in terms of generating new ethical knowledge about the subject of investigation. So this is, what are the ethical issues arising? Should we be concerned about it? Should we be celebrating? I think another concern that people often have about ethics research is to think of the ethicists as the people stood over someone's shoulder saying, don't do that, that's wrong. Ethics can be an opportunity in terms of we can look at reasons for why we should be doing something. Because we're mostly familiar with ethics and governance, we think of it as rules that might stop us, reasons to not do something. We can also use ethics to explore why we should be doing something. It's not just about the harms and the risks, it can be about the benefits. And we can look at the world in terms of trying to balance that. But ethics as inquiry can help us understand the reasons to do something. It can very much support research. So we definitely need both ends of the spectrum for research in AI and precision psychiatry. We need both kinds of knowledge, and we should be developing knowledge about the subject of investigation. This will help us guide the research agenda. Ethics starts before we even start that funding application form. Should we even be doing this? It helps us facilitate benefits, it helps us minimize harms that can result from what we're doing, and it can facilitate acceptability in patient and public populations, and it can help build trust. And we should also be looking to develop knowledge about the ethical conduct of research, which helps us protect research participants and will facilitate trust in research. So ethics as governance and ethics as inquiry are both important, but ethics as inquiry can help us build knowledge about how we should conduct research and about what we should be researching in. So rapidly, so there's lots and lots of scope to conduct ethics research alongside research into precision psychiatry and AI. There are issues around recruitment and consent, and lots about regulation. I'd like to propose the embedded ethics research as a nice way to do this. So this is not somebody who is just sat working separately from you, it's somebody who's actually embedded in the team. And I can see my time is up. 5 minutes goes incredibly quickly. I have to run straight away. I've got to go and be on an interview. My apologies. I'm easily findable. If anyone has any questions or would like to discuss how to do this, get in touch. And if I can't help, I can put you in touch with somebody who can.
Thank you for having me, everyone. I'm going to talk about data hazards, which is a project that I've been working on since 2021. So we've heard a lot about interdisciplinary nature of precision psychiatry and the importance of working as an interdisciplinary team in this field. And we've also heard about the importance of doing good data ethics and good ethical processes within that. The thing is, AI moves so quickly, and we've seen that in the last couple of years with the rise of generative AI especially, that it's actually very difficult for a lot of processes and regulations and laws even to keep up with the speed of what's happening and the potential also for its impact on patients, on people who use the technologies we're developing, and even on society in general that we might not even be able to anticipate yet. And so to do this kind of conversation about what good ethics means in these spaces, to do those conversations in the context of sometimes very complex interdisciplinary teams that might also involve patients and the public, it might involve policymakers, it might involve people who have never really thought about AI ethics before. How do we have good conversations about that in a way that's meaningful and productive? We also know in general that in AI ethics, we need some stronger tools for harms discovery, for future thinking about what's going to happen potentially with AI tools, for involving the public, and also some community consensus about how we're going to talk about these things. So the Data Hazards Project is a community-led initiative, and by that I mean that anyone can contribute to it. And so in steering a project in that way, as a grassroots kind of building up from the bottom, we're hoping to gather as many different perspectives as possible and therefore make the resources as useful as possible. It's a shared open source vocabulary, which means that we're defining the types of ethical harms that we're concerned about and how we can kind of define them in a way that makes them clear for lots of different audiences, and we can all get on the same page very quickly and have useful conversations about them. Data hazards look a lot like chemical hazards. You might recognise them if you work in those sciences, or even if you've picked up a bottle of bleach in your house before, you've probably seen something that looks a bit like that. And they come with a very similar kind of ethos, which is just because something has a risk or a hazard, it doesn't mean that we should be pursuing that technology or that application. It means we need to do it with a really good awareness of what the risks are and with mitigations for those risks. And we need to be thinking about that really early on, just like Jonathan's just said. That needs to be a process that we do throughout research, not just as one single barrier in a research ethics application. Or in some instances, a lot of AI research doesn't actually touch research ethics in some senses because it might not involve participants and the future kind of applications in society might still be very far away. So it's not even always necessary to go through those institutional kind of barriers or hoops as some people kind of describe them. The ways that we use these labels and the ways that we've tried them out so far have been trying to get researchers to engage in interdisciplinary discussions about the ethics of their research. And that's been by holding workshops and inviting people to come present their projects to a range of people from different backgrounds and hear their conversations about the kinds of things that are coming up to them and worries they might have about the future applications of these technologies. The kinds of questions that we ask are around kind of future thinking of what's the worst case scenario, what could happen? And that's a scary process for some people. So it's also been important to develop alongside the process of how do you facilitate those conversations in a way that's safe for everyone that's involved, in a way that encourages researchers to feel safe to be reflexive and reflective about their research, and to kind of take forward the suggestions from people and think about how they could mitigate potential hazards or harms. And the kinds of things that can go wrong are all sorts of things. Sometimes if your research works exactly as it's intended to, that could generate some kind of risk that's different to what happens if it goes wrong. Sometimes if a technology is created for a certain output or a certain context and is applied in another one, that could also create a whole different set of harms that may not have been considered before. So there's lots of avenues to think about these future potential harms as well. So I've been talking about them, but here's what they actually are at the moment. This is version 1.0 of our data hazards vocabulary. And you can see the website at the top. If you're interested, you can go to the website and find out a bit more about it. The kinds of things that might be relevant, especially when we're thinking about precision psychiatry, which do align with traditional ethics processes and go beyond. Things like reinforcing existing bias. And that might just look like having an imbalanced data set, which doesn't, for example, classify well if you have lots of people with lighter skin in your data set, not as many people with darker skin. How does that technology then extend and actually be applied in the real world? That's something we need to think about. What does it mean to classify or rank people? And that's a really interesting one in the context of mental health, when we're thinking about the social meanings of classification and mental health attribution of diagnoses. Lacking community involvement is also super interesting in terms of how we think about public participation in AI and data science fields. How do we involve people in really heavy data-focused research? I think we can, but we need to think more carefully about how we do it well. So that's me done. Thank you very much, and come find me.
Hello, everyone. So my name is Osman Yar, just Ossie for short. And I've been a doctor for about 9 months, which means in comparison to many of my colleagues here, I'm basically the equivalent of a medical infant. So I'll be soon venturing into community psychiatry, where AI's potential and challenges are very clear. We've all engaged with AI, from advanced diagnostic tools to chatbots, and it's very exciting and perhaps daunting to observe the rate of change. So it's crucial that as clinicians and researchers, we stay adaptive yet rigorous as we integrate this technology into our everyday lives. So I'm here to engage with many of yourselves, but to share my perspective as a junior doctor. As junior clinicians, we're not just the future of clinical practice, but in the field where often it's improvisers, testers, and sometimes, unfortunately, it's crash test dummies. So now let's look at how healthcare is going to be reshaped. So as you can see on this slide, on the one side we have the traditional overwhelming aisles of medical records, a familiar sight in healthcare that symbolises the substantial administrative load that doctors and nurses carry. And the other image, perhaps, represents a glimpse into the future. Perhaps a clinician using advanced AI to analyse patient data, to collaborate on complex decisions, or perhaps even an AI giving advice how to explain the disease to a patient appropriate to their level of knowledge. In just 5 years, the day-to-day responsibilities of a doctor, especially in psychiatry, will shift dramatically. Currently, up to 50% of a psychiatrist's time is consumed in administrative tasks, tasks that are crucial not just for clinical care, but often serve as legal documentation in court cases and tribunals. And this is where AI comes in, offering technologies like AI scribes and administrative tools that can free us from the burden of paperwork, allowing us to focus on what really matters: patient care and evidence-based medicine. Now, the transition will not be without challenges. Despite the existence of advanced technologies like MRIs and mRNA technologies, we can still grapple with outdated practices like paper-based records. So there's going to be a stark contrast in the adoption of this technology throughout the NHS. In Bristol, we still use paper records. A lot of people don't know that. So let's look at the ethical side, which Nina spoke about brilliantly, of using this technology. So as you can see in this slide, there's a balance between technology and ethics, much like a tightrope walker. And then on the other side, we have what I like to call the clinical innovation iceberg. At the top of this iceberg, we have regulated innovation. And these are implementations that have been tested, approved, and come with clear rules. And a lot of that testing is done, a lot of that planning is done prospectively. And drug research specifically is really great at getting this right. At the bottom, we have unregulated innovation. Now, these represent more complex implementations. These could be surgical technologies, workflow optimizers that aren't fully checked and are often analyzed retrospectively. Here at Bristol, we're quite lucky. Researchers are actively involved with the Introduce trial in pioneering new guidelines for complex innovation, specifically in surgery. And this rigorous academic work is going to be critical because it's really going to help us define the frameworks that we use to help integrate AI. So we've discussed the exciting potential AI holds. We've talked about its ethical landscapes, but I'm also now going to speak a little bit about how we as juniors can help contribute towards safe and effective integration. Now, our slide here visualizes a basic feedback loop showing the dynamic between clinicians, AI tools, researchers, and patient outcomes. And this cycle is pivotal for continuous improvement in healthcare. To bridge the knowledge gap between clinicians and AI developers, we really need to foster a collaborative environment, which is why I'm very happy to be here today. We need regular feedback sessions, joint workshops, and pilot studies. And these are just a few ways in which we can influence the refinement of AI tools. These are going to ensure that these tools are both clinically relevant and user-friendly. In practical terms, there need to be systematic ways to document and report how AI tools perform in day-to-day tasks, whether through digital feedback mechanisms or educational programs. By engaging in these processes, we're not only going to enhance our own clinical practices, but contribute towards the evolution of the broader medical field. So I look forward to collaborating with people here and making this a reality. Thank you for listening to me. My time is up.
This is actually a joint talk, really. My partner in crime is Freddie Brown, who can't be here today. He's a clinical psychologist who works with autistic children, mainly specializing in the application of relational frame theory techniques and acceptance and commitment therapies. So why I'm here, we're actually about to start writing a project proposal, and kind of this coincided at the same time you're having this meeting. So I just wanted to see if anybody's interested in joining us. This would be a good opportunity. This is actually a brand new project. In terms of AI, so we want to apply AI to clinical psychology. We're really talking here about large language models, which is your things like ChatGPT, although it's a lot more nuanced than that, and potentially relational machine learning and even robot-enhanced therapies. And in the clinical psychology, as I said, the acceptance commitment therapy, sorry, I should say therapy, not theory, and relational frame theory with long-term, hopefully, applications to autism therapy. To give me some credibility here, what I've done in the past is 2 projects. So one of them, we took an owl robot, an off-the-shelf robot, and we had a PhD student program it, and it could actually deliver RFT-based scripts, which are carefully controlled conversations to basically enhance the formation of so-called deictic frames in young children, which is their perspective-taking skills and theory of mind and understanding perspectives of themselves and others. And we successfully did that. It has a limited number of scripts that it could do, but the robot could. It could identify the table, the objects on the table, the subject, what pictures are on the cards, their animals and foods, and then we try and teach the child relations, transitivity, reflexivity, so on. So that was kind of our first working together with Freddie, and that is Freddie there, supervising this test session, basically. This was a neurotypical child, just a test to show that we could technologically do this. I currently have a student working on application of large language models to basically acceptance commitment therapy, where you have these 6 variables that clinicians are interested in tracking. And we basically have different large language models all running in parallel, each one of them, these 6, studying these key variables as the conversation is developing and proposing what to say to the child. Then we have like a coordinator agent, and you have to be careful like what large language model you use, because they have different context windows, different prompting windows, different capabilities. And my student happens to be an expert in all of that stuff and how to fine tune it and how to do, various tricks of the trade. So those are the 2 things that we worked on. But what we concluded from that, what we want to do is something slightly different now. We're going to stop working with robots for a bit. Robots, even when they're standing still, they're using energy, their motors are working, they overheat, their batteries run out, and literally they do shut down in the middle of a session. So we've had examples like that. It's technically hard, and maybe the real challenges are more in the cognition behind it. So we want to stop robotic development temporarily, and also dealing with patients directly because of too many ethical hurdles that we have to go through. And what we've come up with instead is let's work with, sorry, this is a bit small text, let's work with therapists and produce a training tool for therapists. So basically, so as Freddie wrote some of this here, it's a myth that experienced therapists produce better outcomes. There have been studies on this. Actually, the effectiveness of therapists decreases as they get more experience, although their confidence increases. And so there are various reasons for this. Clients at the beginning, they're not tracking the real clinical variables. They're how well do I feel and how good do I feel, rather than is meaningful change happening. And also they're only the patient, so they can't really give feedback to the therapist. And supervision sessions help, but there's limitations to those. So we kind of want to kind of leverage what we've been doing so far. Sorry, let me go back. So make these LLMs, large language models, trained on clinical transcripts. And currently the model, you can actually generate transcripts, but we wanted to basically analyze transcripts of conversations that therapists have had with patients. And this is going to be in the context of focus ACT. They're very interesting paradigm. You just have a 15-minute session and you focus therapist on making one meaningful change for the subject. This could be done over the phone potentially. And then the tool would provide feedback. It would effectively look at the therapist's report of what's happened and make its own report and then be able to compare the two. So, so if you're interested in becoming involved in that, either on the AI side or on the evaluation side, or the clinical deployment, or there's many angles to consider. But Freddie and I are going to go ahead and do this. If you're interested, come see me at lunch or email me, or Freddie if you can find him as well. Okay, thank you very much.
So my interest in this, I'm in computing at UE Bristol. My interest in this stems from a few years back. We developed a self-help app for mental health called STAM, which is now in its second iteration. Developed with colleagues using a sort of UX, user-centered design process. And we now have an entity which manages the app as a spin-out, but not quite the kind of spin-out that my university would really like to have. Not one that makes millions of pounds, but one that can just look after it day to day. We've done a bit of research on the app, starting with looking at engagement patterns of the user base, finding that there's this massively long tail of attrition that you get with apps, tends to happen, but also that there's some specific kind of interaction groups, people behave differently within the app. So that was published in JMIR. We're now doing research around personalization because this is an area that we feel needs examination. There's often a sort of a priori assumption that better personalization will lead to more engagement and better impact. But when you actually look at the evidence for this, it's not really that clear. So we feel that needs more work. So the question is really, is personalization really better for engagement and outcomes than things like collaborative filtering, so just using the community's favourites to rank the self-help. We've done a scoping review around this, which is coming out soon, behaviour and information technology. And yeah, as we say, evidence is mixed. There's not been any really good reviews on this, reviews on the evidence. So we are currently doing a multi-arm trial looking at adaptive personalization as one arm, but comparing that to more sort of broad brush community-based ranking. And my colleague Clem, who's here, is working on that and managing a study. So if you want to talk to her about that, she's available. Possible collaboration around this is we have a sort of customizable, flexible content publishing system. So I'd be happy to talk to anyone who might be interested in tailoring content for specific audiences. You could then customize the app to give to particular groups. Because we have research opt-in when users sign up, we have a base of people who are prepared to take part in studies. So that's one area that I wanted to talk about. The second one, which I'm just starting to get into, is chatbots. I find this really interesting from a sort of an ethical perspective as much as anything, and a sort of human AI interaction perspective. The fact that these are burgeoning now, lots of people are already using them. We've got to sort of figure out what the hell's going on. We've got to embrace the reality. There's this concept of the ELIZA effect. I don't know if you know about ELIZA. It was one of the first chatbots back in the 70s, I think it was. That was very simple, very sort of automated script that just sort of repeated back what the client was saying, but people actually found it really engaging, really immersive, and people thought it helped them. So what we're doing around this at the moment is a small-scale study fine-tuning some different language models based on real therapist-client questions and answers. And we're just blind testing that with students to say, do you find this response supportive? How supportive do you find this response? And we're finding that the language models are performing surprisingly well, although the human therapist is still the best rated answer. Thank God. Two of the language models are producing responses that are mostly rated as very supportive by the subjects. So this is quite an interesting finding, I think. Happy to talk to anyone who's interested in this work, scaling it up, different kinds of models, maybe a model with a memory, or building a model of the interlocutor. Yeah, and the whole area of AI-human interaction is fascinating. Should these bots be imitating people, or should they be something a bit different? Should we be keeping a mental distance from who we're talking to? That's me, thank you.
Anxiety disorders. Anxiety disorders still face mis- and underdiagnosis. And this is also due to the difficulties in differential diagnosis among subtypes, but also due to the fact that there are so many co-occurring comorbidities with anxiety disorders, and somatic also complaints. Nowadays, the standard methodologies are relying on self-reported surveys and of clinical interviews, which are great, but come with some limitations. And we have that we are not collecting data in real time, and this is causing the risk to have the recall bias. Recall bias is essentially the fact that we are not very capable of reminding well how we are feeling the past. Moreover, there are some limitations in the healthcare system nowadays, lack of clinicians, and so the doctors, psychiatrists, psychologists have less and less time to spend with their patients. Moreover, the meetings are taking place mostly in controlled environments, clinics and hospitals, far away from the daily scenarios, which are the triggering events, which elicit the disorders in patients. And what we are trying to do essentially is to explore if and how technology can help in mitigating these limitations. Emotions are responses to outside events, and standard self-reported approaches essentially analyze them already, but they've been criticized to be paradoxical in evaluating the emotional responses of people. Moreover, clinical interviews may lack in specificity and also in cross-cultural validity. So what technology can add to this? Essentially, technology can open us to monitor emotions in different modalities, new modalities, which range from analyzing the bio response, the physiological responses of the body, which are essentially a mirror of the autonomous nervous system. And we can also collect longitudinal self-reported data, such as surveys, diaries, audio and video recordings. Previous studies show that multimodal approaches outperform unimodal ones. So what we are proposing is to implement commonly available, commercially available devices, such as wearables and smartphones, which are free from the stigma which is usually linked to medical devices, and are also available, easily available to the public, and to implement them in the clinical practice. These devices allow us to collect wave signal, both passive, such as PPG for heart rate, just hour for galvanic signal response, but also active, such as one-lead ECG, and of course also longitudinal self-reported data. The problem is that study also say that in 3 months, there is a 50% rate of dropout for digital solutions in mental health. So to address this historical challenge, we are embracing a co-design approach, which involves users, which involves patients and clinicians, since the beginning of the design process of the solution. This will range from analyzing the problems and the needs till the evaluation of the solutions once active. So which kind of self-reported modalities should we include? How should we display this data? How should we share the data with clinicians and other stakeholders? When the solution should interact with the user, send notifications, and whatever. All these aspects will be covered in this process of co-design. Yes, if you are interested in collaborating with us in co-designing solution, see you at lunch. Thank you so much.
Thank you.
Hi, I'm Jess. I'm based in the NIH Arc West, and I work on general healthcare research and qualitative healthcare research. So I was a little bit uncomfortable about even putting myself forward for this, but I'm really interested at the moment about how we are using or talking about using AI in qualitative health research. And I thought you might all be a little bit further along the line. And although the word precision makes me think of neuroscience and brains and tissues, I am also aware that psychiatry is all about also relationships and symptoms which are understood through talk, and even the way that we understand and present data of brains and tissues has a narrative that is within the realms of qualitative research. So I know this stuff is going to be relevant to your work in some way, and I think I'm probably, and perhaps as a community, we've had some meetings recently about AI in qualitative research, and I think you might be a little bit behind where you are at in terms of the work that you're doing, and that's kind of why I thought I might as well come. I'm not sure that you have so much to learn from us, but I'm interested in talking. We have a lot of concerns, and that's what I'm interested in both the kind of wonders of it. What can we do with a whole body of text-based, talk-based, narrative-based, observational-based data that AI might help us with? But also the way in which the ethical concerns are very, very relevant to us in terms of the communities that are represented in that data marginalised communities, underserved communities, people of colour, people from economically disadvantaged communities who are much, much less represented in all of our data, and that becomes a huge problem when you're looking at qualitative data and the things that we might learn from that, but also much more generally in AI data once we start to make bigger generalizations. And what we are trying to offer at the moment is also applications which come from AI, which might be really useful assistance that might support deficits in the healthcare provision where there's not enough time to spend with people, but you can have your AI assistant. And I actually know people who are working in companies outside of our research communities developing ADHD AI assistants, developing tools for journaling, which will allow you to go on self-discovery and sort of very deep processes. So it's happening. And we don't know about the quality of the data that is being used in the generation of those apps. Of course, people who are doing that within the research community are very concerned about that. But my interest is in funding for research which explores this, that in a meta sense, how we are doing this AI research helps us to have guidance which allows us to be transparent in the way that we talk about the AI that we've used. So I can imagine ways in which AI might be very helpful in very speedily characterizing some of our data sets. But I want to know what the human engagement has been with those data sets. Reflexivity is a huge issue for qualitative research, understanding not just the context of the data, but our context as researchers and the way in which we interpret the data. It's all about interpretation. It's not just about having confidence that the data has been accurately represented. There is also this level of interpretation. It's data, not just of the brain, but in a person, in a social environment, and all of those layers. And I think that's relevant across the board with AI, but it's particularly relevant with qualitative research. And we have amazing tools where AI might be able to be reflexive in that you can say, okay, I want a qualitative researcher to look at this data and analyze it from the perspective of this political perspective, or someone who's been living in this particular country. We might be able to generate AI tools that allow us to do all sorts of interesting things. But what does that do? How good are they? And I think it's that level of meta questioning and an evidence base that allows us to say, this is as good as it is right now, we should do more. And I'm interested in funding that will allow us to look at that evidence base.
So I'm Christopher Woods. I'm helping to build the Elizabeth AI supercomputer. So this is a ridiculously fast project, and this will be a ridiculously fast talk. So basically started when the government realised that it was not funding AI last year and we should rapidly fund AI. So they started the project where we signed it in November, and we've built the computer for delivery basically this year. It's already actually in a car park working. This is the car park, or at least it was the car park. We've dug this car park up and we're basically placing containerized data centers down here, which will hold the UK's largest AI supercomputer. Operational, small part now, but the large bit, the main bit, will be actually running in the summer. They're going into these containers, basically like shipping containers lowered in. What you see there on the bottom left, that's actually what Elizabeth AI Phase 1 looks like. It is a small little cabinet sat at the back, like a wardrobe, 200 kilowatts. It's one of the fastest computers in the country. And that's just the baby. The big one's going to be much larger. But what is it for? It has been funded specifically by the Department of Science, Innovation and Technology to do AI and also to do AI safety. There's the AI Safety Institute, which is the government's AI safety group in Whitehall. I was visiting them on Tuesday, who's going into the ethics of AI in depth. They have a budget of something like 50 to 100 million pounds a year. They'll be handing out grants. I encourage everyone who's talked about ethics today, please look up the AI Safety Task Force, the AI Safety Institute, because they are the people who are answering the questions that you've been raising in the talks at the moment. It's for that AI safety, it's for large-scale inference, training large language models, hybrid AI simulation workflows, blah, 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 but it's to work at any scale. It's to get the research community to go from their laptops quickly up to 1 GPU, 10 GPUs, 1,000 GPUs, 5,000 GPUs, quickly. Why are they doing this? Why are they giving us the equivalent of £1 million a week to get this running? It's a £300 million project. It is because artificial intelligence is moving from a computer science to computational science. If there is a pattern in your data, whatever the data is, the computer will find it, and then you can make predictions from it. The software is now accessible. It's quite easy to use. You can actually learn how to use AI tools in about 2 weeks. I encourage people to do so. And as the size of your data and the size of your model increases, so does the capability of your AI. To the point you have this thing called emergent AI. This is a really nice picture of it. When you started off, this is from Google, when they had an 8 billion parameter model, all it could do was language understanding and arithmetic and question answering. But as more data went in, as more parameters were actually built up, hopefully it'll play. Oh, the movie doesn't play, that's a shame.
Let's play it, yeah.
You want to see the movie?
Yes.
As you see the movie, as you put the parameters in, it can do summarization, translation, question answering, arithmetic, joke explanation, pattern recognition, logical inference. And this is the thing, you get this explosion of capability just by adding data without changing the code. It is amazing. This is why people are rushing to increase the size of their models. What you see on the left is a plot of the size of models versus time. It's basically 2018 to 2020 in the bottom 2 parts. That is an exponential plot. It's a log-log plot. The size of models have gone from millions to billions to trillions of parameters. Loads of them are appearing pretty much every week or 2 now. You have a new large language model, a new image model, a new video model. It's just huge with amazing capabilities. And this is going to keep happening. The pace of change in this field is monthly. We cannot wait 2 years, 3 years, 4 years before we embrace this change. We have to do this now. How do you get ready to go into this world of AI, which is going to transform all aspects of society, research, and innovation? Basically, look for the communities who are already working in this area. You will find people from Hugging Face. You'll find people, just Google out who is using AI in my field. Things like this. Then think about what data you have, what patterns could exist in your data, what questions you would like to ask of your data. The language of AI, some people do use R, but actually it's kind of coalesced with the network effect into Python. Most AI is now done in a tool called PyTorch. And that's what all of the large language models are. It's a very easy tool to use. I do encourage you to learn it. We have some links here which basically show you how to learn Python from the beginning, how to learn neural networks and PyTorch from the beginning. You can do this on your laptop or even in free cloud resources from the links which are there. So it's actually very easy to do. It will let you scale up your laptop. If that's a very good laptop there, it can basically just run 466 million AI operations per second and 8 gigabytes of RAM. Isambard AI is 5,000 of those GPUs, but actually far bigger and better ones. 384 gigabytes of memory per node. Can run 10.4 million trillion AI operations per second. It will be one of the fastest computers on the planet. And in the UK, we're very lucky to actually be able to have this so quickly. Thank you.
I'm going to give a 2-minute whistle-stop tour of how the Gene Golding Institute can support your research. So those that aren't familiar with the JGI, we're the university's research institute for data science and data-intensive research. And you can kind of see us as a pool of data scientists with a range of expertise that you can utilise to help you with your research. This can range from kind of free data science help desk support, so kind of one-off maybe help, to kind of costing in on one of our data scientists to support your research, so at a fractional FTE from short periods to long periods of time. In terms of funding, we actually also do kind of small pots of seed corn funding, which many researchers have used for kind of proof of concept, then they develop these into kind of larger grants. And we can help with kind of helping with grant development, so costing advice, and then looking at experimental design and data ethics. What else? We've got training. So we do a range of training. So from kind of simple coding courses to more bespoke workshops. So if there's something that you want to have training in more specifically, you can speak to our data scientists and we can develop something more bespoke. And then finally, we do a whole range of events. So from seminars, discussion groups, which we organise ourselves. Which is quite topical because we have Bristol Data Week from the 3rd to the 7th of June, which is a range of seminars, workshops, online and in person, that showcases all the kind of exciting data science research we hold across the university. And one of these days is actually in City Hall, and it's all about AI and the future of society, and that's honestly you. So please do join us. If you've got any questions, just give us an email. The QR code has all the different ways you can contact us, or speak to me and Hugh, who's sat here, in the lunch. Thank you.